is making you lonely, you can always go downtown. Just listen to the music of the traffic in the city. Linger on the sidewalk where the neon signs are pretty. How can you lose? Forget all your troubles, forget all your cares, so go downtown. Things will be great when you're downtown. No finer place for sure, downtown. Everything's waiting for you.
The following program is rated G. It is suitable for all audiences.
Go.
Good day, netizens!
I'm Kate Lisa.
And I'm Jamel Bagasan. Welcome to another episode of Earth and Life Science, where you and the world are connected. Did you know that about 300 million years ago, when Europe, Africa, America, and the other great continents were one big landmass, this famed supercontinent was called Pangaea.
Jamel, Colleen, and John are here with us to share their knowledge about how they split up and moved to their modern-day position.
Okay, so what is plate tectonics? Plate tectonics came from the late Latin word tectonicus, pertaining to buildings. It is a scientific theory describing the large-scale motion of 7 large plates and the movements of a larger number of smaller plates of the Earth's lithosphere. Over the hundreds of millions of years, the models built on the concept of the continental drift, an idea developed during the first decade of the 20th century. The geoscientific community accepted plate tectonics theory after the seafloor spreading was validated in the late 1950s and the early 1960s. The lithosphere, which is the rigid outermost shell of the planet, is broken into tectonic plates. The Earth's lithosphere is composed of 7 or 8 major plates and many minor plates. Where the plates met, the relative transformation occur along these plate boundaries. The relative movements of the plates typically range from the 0 to 100 mm annually.
Tectonic plates are composed of oceanic lithosphere and thicker continental lithosphere, each topped by its own kind of crust. Along convergent boundaries, subduction, or one plate moving under another, carries the lower one down into the mantle. This way, the total surface of the lithosphere remains the same. This prediction of plate tectonics is also referred to as the conveyor belt. Earlier theories, since disproven, propose gradual shrinking or gradual expansion of the globe.
Tectonic plates are able to move because the Earth's lithosphere has greater mechanical strength than the underlying astrosphere. Lateral density, variation in the mantle, result in the convection. That is the slow, creeping motion of Earth's solid mantle. Plate movement is thought to be driven by a combination of the motion of the seafloor away from the spreading ridge. Another explanation lies in the different forces generated tidal forces of the sun and the moon's relative importance of each of the factors, and their relationship still the subject much debate.
Shifting of tectonic plates are one of the major causes of some naturally occurring disasters.
One of these examples are the violent shaking of the Earth's crust, or famously known as an earthquake. Mary Jane, JJ, and Renald are here with us today to give a little background about the earthquake.
Earthquake is what happens when the two blocks of the earth suddenly slip past one another. The surface where they slip is called the fault or fault plane. The location below the earth's surface where the earthquake starts is called the hypercenter. And the location directly above it on the surface of the earth is called the epicenter. Sometimes an earthquake has force shock. There are smaller earthquakes that happen in the same place as the large earthquake that follows. Scientists can tell that an earthquake is a foreshock until the larger earthquake happens. The largest main earthquake is called the main shock. Main shock always have aftershock that follows. These are smaller earthquakes that occur afterwards in the same place as the main shock. Depending on the size of the main shock, aftershock can continue for weeks, months, and even after the main shock.
The Earth has four major layers: the inner core, outer core, mantle, and crust. The crust in the top of the mantle make up a thin skin on the surface of our planet. But this skin is not all in piece. It is made of many pieces like puzzle covering the surface of the Earth. Not only but these puzzle pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces tectonic plates. And the edges of the plate are called the plate boundaries. The plate boundaries are made of main faults, and most of the earthquakes around the world occur in the east coast. Since the edges of the plates are round, they get stuck wide. The rest of the plate keeps moving. Finally, when the plate has moved far enough, the edges unstick on one of the faults and there's an earthquake.
While the edge of faults are stuck together and the rest of the block is moving, the energy that would normally cause the blocks to slide past one another is being stored up. When the force of moving blocks finally overcomes the friction of the jagged edge of the fault and it unsticks, all that is stored up energy is released. The energy radiates outward from the fault in all directions in the form of seismic waves, like ripples on a fountain. The seismic waves shake the earth as they wave throughout. And when the waves reach the earth's surface, they shake the ground and anything on it, like our houses and us.
Sandali na lang to, baby.
Magkapinyam, magkapinyam, masarap, masarap, kinakama masarap, kinakama masarap, pinyam, pinyam.
Manang-mana ka talaga sa daddy mo.
Yeah.
Basta toyo, marka pinya.
Pinya!
Good afternoon everyone. Narito po kami para tanungin si Miss Mara Jane Abio. Miss Mara Jane, maaari po ba namin kayo tanungin? Sige na. Para po sa inyo, ano po ang yung earthquake?
Earthquake para sa akin, ito yung isa sa pinaka-delikado na maaaring mangyari sa atin. Ito ang paggano ng lupa sa mundo.
Sa earthquake, ano po ang mga kailangan gawin kapag naranasan po natin ito?
May naturo sa amin yung pinakamadaling paraan. Ito yung back cover and kung saan pupunta ka sa ilalim ng lamesa or kahit saan ilalim. Tapos, mag-hold ka.
Thank you po sa oras niyo. Maraming salamat. you know that tsunamis are a long high sea wave caused by an earthquake, submarine landslides, or other disturbance? It is an arrival or occurrence of something in overwhelming quantities or amounts.
So how do tsunamis occur? Tsunami are actually waves caused by sudden movement of the ocean due to earthquakes, landslides on the seafloor, and slumping into the ocean, major volcanic eruptions, or large meteorite impacts.
When do tsunamis happen?
Most tsunami are caused by large earthquakes at the seafloor, when large slabs of rock are forced to move past each other, suddenly causing the overlying water to move. The resulting wave moves outward and away from this event.
While an immediate effect of a tsunami is the destruction of life and property, tsunamis also create a health crisis. Not only do tsunamis wipe out buildings and carry many of the things in their path away, they leave behind a crippled infrastructure that makes it extremely difficult to provide basic services to the people who survive.
Tsunami happens when earthquake, landslides, or volcanic eruptions disturb the ocean floor. Most tsunamis occur when there are earthquakes at tectonic plate boundaries. When the ocean floor at the boundary rises or falls, it moves the water above and creates the huge waves that become tsunamis.
Back to you, Jomar.
In the year 1991, not only the people of Zambales, but of the whole country, suffered the great loss of lives and properties due to the eruption of Mount Pinatubo.
So what causes a volcano to erupt? Hi! So we're going to experiment about how volcano erupt. So ito yung mga kailangan.
from which lava and other igneous rock is formed from cooling. As already noted, both lava and magma are water sources from rock superheated to the point where it becomes gaseous and molten. But again, the location is the key. When this molten rock is located beneath the earth, it is known as magma. The name is derived from the Greek, which translates to think unguent, a word used to describe a viscous substance used for ointments or lubrication. It is composed of molten or semi-molten rock, volatiles, solids, and sometimes crystals that are found beneath the surface of the earth. The viscous rock usually collects in a magma chamber beneath a volcano or solidified underground to form an intrusion, where it forms beneath a volcano. can be then ejected into cracks or rocks or issue out of the volcano in eruption. The temperature of magma ranges between 600 degrees Celsius or 1,600 degrees Celsius. So what do we mean by magma? Magma is a hot fluid or semi-fluid material below the Earth's surface, from which lava and other igneous rock is formed by cooling. As already noted, both lava and magma are water sources from rock superheated to the point where it becomes viscous and molten. But again, the location becomes viscous and molten, and the location is the key. When this molten rock is located within the earth, it is known as magma. The name is derived from the Greek, which translates to peaks on rest, a word used to describe a viscous substance for ointments or lubrication. Magma is also composed of molten and semi-molten rocks, volatiles, solids, and some crystals that are found beneath the surface of the earth. This viscous rock usually collects in a magma chamber beneath the volcano to solidify the underground to form an intrusion where it forms.
Magma is a hot fluid or semi-fluid material below or within the Earth's crust from which lava and other aqueous rock is formed by cooling. On the other side, lava is also hot molten or semi-fluid rock erupted from a volcano or fissure, or solid rock resulting from cooling events. When magma reaches the surface and erupts from a volcano, it is officially becomes lava. There are actually different types of lava depending on its thickness or viscosity. Whereas the thickest lava can flow downhill for many kilometers, thicker lavas will pile up around the volcanic bed and harden slowly. The thickest lava doesn't even flow and just flood up to the throat of the volcano, which in some cases cause violent explosion. The term lava is usually used instead of lava flow. This describes a moving pouring of lava, which occurs when a non-explosive effusive eruption takes place. Once a flow has stopped moving, the lava solidifies to form things materials. Although lava can be up to 100 times more viscous than water, lava can flow over great distance before cooling and solidifying. When volcanoes erupt, they emit a mixture of gases and particles into the air. Some of them, such as ash and sulfur dioxide, have a cooling effect because they are the substance they cause to reflect sunlight away from the earth.
That's all for today's episode.
Once again, I'm Kate Giza.
And I'm John Martagasan. This has been Earth and Life Science, where you and the world are connected.
The following program is rated G. It is suitable for all audiences.
Grandpa shark, do 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 do. Grandpa shark, do do do
show